Now in this lecture we will be discussing the numerical problems based on the EMF equation, that is in transformers, right? Okay, now first we will see the question. So it is given that a 220 volt by 440 volt single phase transformer has 1000 turns on primary side and the maximum flux density in the core is 1.2 webers per meter square. Then we have to calculate the number of turns on secondary, area of cross section, as well as maximum flux in the core. So first, whatever be the problem given, whenever you have some problem, first you need to write down the given variables or parameters or quantities. So from that you need to get the variables which has to be assigned to the particular numbers. So if you see 220 volts by 440 volts is nothing but E1 and E2 of the transformer, and N1 is the number of turns which is given as 1000, and Bm is the maximum flux density of the core, that is given as 1.2 webers per meter square, which is nothing but Tesla. So now we got the relationship of number of turns and induced EMFs, that is E1 by E2 is equal to N1 by N2. So from this you can get N2 is equal to N1 into E2 by E1. So if you solve this you will get N2 as 2000, right? Then we need to determine maximum flux in the core, but we are given with the flux density. So then how to get it? So we have the relationship of flux density is equal to flux per unit area, that is divided by area of cross section. From this you can get the area is equal to pi m by bm. Okay, but from where we have to get pi m? So we can get this pi m, that is maximum flux, from the EMF equation. So which will be like E1 is equal to 4.44 into F into N1 into pi m. So here F is frequency. So if nothing is given, you can assume it as 50 Hz, and N1 we have to get N1 value, or it is already given as 1000, fine. And E1 we know, and pi m is the only unknown from this equation, so you can get pi m value. Right, then if you substitute that pi m and bm in this equation of area, you will be getting what you can get area, fine. Yes, that is about this numerical problem. So we will discuss one more numerical problem. So right, so this is another numerical problem based on the EMF equation. So here if you see, as per the given values, the core of a 100 kVA 11 kV by 550 volts 50 Hz single phase core type transformer has a cross section of 20 centimeters by 20 centimeters. So you need to observe here the units are given in centimeters, but Tesla, if you want to determine flux density in Tesla, it will be Weber per meter square. So in that case you have to convert centimeter square into meter square, right? And we have to determine here the number of HV as well as LV turns per phase. Anyways, it is a single phase transformer, so no problem. And the second part of the problem is the EMF per turn if the maximum core density is 1.3 Tesla, right? Tesla is nothing but Weber per meter square. So again we have to get the all known values here. So area is equal to 400 centimeter square, which is nothing but 20 into 20, and we have 100 kVA 11 kV by 550 volts and 50 Hz transformer. So from EMF equation here, we have E1 is equal to 4.44 pi m f n1, and from this you can get number of turns n1, right? If you see here we are converting this centimeter square into meter square, then the area will be 400 into 10 to the power minus 4, right? So from this you will be getting n1 value, and if you use this relationship of E1 by E2 is equal to n1 by n2, you will be getting n2 value, right? So further, uh, I think here in this equation of EMF we need pi m, right? That pi m we are getting using the relationship between flux density and area of cross section. So like this we will be getting flux. So using this flux, if you substitute this in this equation here, you will be getting E1, and that E1 has to be, sorry, if you solve this equation you will be getting N1, and using this N1, if you use that N1 here, you will be getting N2. Fine. So then they also asked EMF per turn. So what is EMF per turn? EMF per turn is equal towards the both primary as well as secondary sides, which is nothing but E1 by N1 or E2 by N2. Since you have both the values of E1 and N1, you can get the EMF per turn. Right? This is how you can solve the problems based on the EMF equation in case of transform. That's it. Thank you.